So in this video we're looking at alternate rays that you can draw for your ray diagrams. This is for concave mirrors, convex mirrors, concave lenses, convex lenses. So let's just set up one here. Here's our concave mirror. We've got our focal point and we've got an object right there. So before I said you can draw a parallel ray that reflects through the focal point. That one you should always draw, I think. It makes sense. It's one of the most easiest ones you can draw. And previously I've said to use equal angle reflection right at the center of the mirror. But what I'd like to offer you now is one which goes through the focal point and then reflects parallel. Okay, so I'm pretty sure that one wasn't covered, and that should give you the same image location, so it crosses over at the same point as your equal angle reflection that we did before. Okay, so that's just one alternative that you can do. For the convex mirror with the virtual focal point and 2F, this is one I sometimes get a little bit mixed up with, but you can draw it fine and dandy over here. The first one that remember we stick with is our parallel ray that reflects as though it comes from the focal point. And now interesting, I'll set this up in just a little different way. If you have a circular mirror, any ray that originates right at the center should pass straight through the edge with no okay, this is a little bit tricky because it's a mirror. It obviously can't originate anything from the inside of it, but if it was a glass ball so that it could go straight out, it would go straight out with no bending at all. And if it was a mirror and you were to shine it straight in at that point, it would also reflect straight off at that particular part of the surface. So that's when you're considering the radius right at the center. So that's why we can say any ray that comes from straight down here, like where the base of the object is, will reflect in the same direction. Okay, so you could go dot 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 back, and that would show you where the base, somewhere along that axis, is where the base will also be. Okay, but what we're dealing with here is from the top of the object, because that's where we need to find it. But if we have a ray that goes from our top of our object straight through to the center of rotation, like we have here, it will bounce straight back. So we could draw a ray that goes through, and it would appear to originate at the center of rotation if we were just considering that one single ray. So that's going to bounce that way and come straight back as well. Okay, so when it bounces back, it'll continue off in that direction, and that gives us our image location. And if we were considering our equal angle law, okay, then it would also, with that being our reflected or equal triangles, we'll stick with that. And if you dot it backwards to where it appears to come from, it also crosses over. So that's another very, very useful light ray. So that geometrically works. We also have a variation for the concave, or for the lenses anyway. Here's our concave lens. We've got our focal point. We've got our other focal point on the other side, and we'll just stick our object there. And here's our first light ray, which we should always draw. And then it's going to spread out as though it comes from the focal point. Okay, and again, we would previously use the straight through at the optical center or the middle point, but we can also go to twice 2F, which is also the center of curvature, and we can have the same effect sort of going on here. So we would have that, let's see if I can, a ray that goes straight through, and this is, okay, I've drawn it a little bit shallow, so excuse me for slightly cooking the result. So that appears to come from this point here. which is where our image would be, because that's where both rays appear to originate. And if we go back to our equal angle, I've done something odd. Yeah, I've done something odd on here. I'll just double check that one and then come back to you. Okay, I've made a bit of a muck up here. So this ray doesn't work. So scrap that. That's quite cool when you draw like that. And we have another go at this. As I said, it's best to stick with the rays that you know well. So there's F on one side, there's F on the other side, and here's our object. Okay, take two for this one. So a parallel ray, which will spread out as though it appears to come from the focal point. And because remember, the big deal about this is that parallel light rays will go as though they come from a focal point, and it works in reverse as well, that rays that are headed towards the focal point, even if it's from the other side, will bend out parallel. That's part of the diverging nature. So in this case, if we take an object here and we aim for the focal point over here, so that's where we've been aiming, that will now bend parallel and appears to come from a point over here. Okay, and that corresponds with our equal angle, our third ray in this case, which we can draw going straight through the optical center, which is really nice. Which appears again, if you're dotting it backwards, dot 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 along on there, it actually appears to come from that same point where the image does. Okay, so that's another alternate ray diagram. And the last one that I want to consider is your convex lens. F and F. Here's our object. You can also draw your parallel ray. That, remember, this one's a converging lens, so it will send it through the focal point. And we've seen the one that goes through the optical center. There's also one where you can go through the focal point and then have it come parallel, and they're roughly in the right place. They should be in the right place if you've drawn your diagram nicely. I'm just drawing them sketchily. So those are the more than enough rays for you to work out where everything goes. I say pick with one or two and then just stick with them. That's the best way, but it's good to know where they all come from as well.